Hello guys, in this video we're going to be discussing the third lesson in the SAT Math Prep, and this is the linear equation word problems lesson. Now in this lesson, we're gonna use the basics of linear equations and our understanding in that lesson to be able to solve word problems. And on the SAT, you can be 100% sure that there will be word problems, for sure. So, and a lot of the time the word problems deal with linear equations, so it's really important that you understand this lesson. So to begin, I recommend watching our videos, the previous two lessons related to linear equations to understand, and getting that, especially if you want to do the SAT Math Prep, I recommend doing it in order. Anyway, now that you're on the third lesson, I'm just going to do a quick revision on our favorite formula for linear equations, and we'll begin. And that formula is the y equals mx plus b formula. And this formula is amazing because it gives you everything directly. It gives you the slope, the increase or decrease, or the rate of change in an equation. It gives you the y-intercept, which is right here, the b-intercept. And of course, you can just plug in your x and y values, and that's just the full equation. Now, this equation is really important because when we're dealing with word problems, they're usually going to ask us about the slope. Sometimes they might have a y-intercept, which is important to note, and sometimes they'll want you to write it in this formula. So it's just really good to make sure that you are familiar with this formula. Now right here I have a basic word problem, very simple, but it'll give us the main idea of how questions might come. So here it says Max cries 3 times a day. How many times does he cry in 2 weeks? So right off the bat I can tell it's a linear equation because there's a proportional constant rate, and right here it's the slope, and it's 3 times a day that he cries. So 3 here is the slope. 3 times a day is the constant rate. And then the question says, how many times does he cry in 2 weeks? Now, sometimes they might change the units. Instead of day, they give you weeks to mess with you. But as we know, 1 week is 7 days. So we just multiply here by 2. 2 weeks would be this multiplied by 2, would be 7 times 2, 14 days. So they're asking how many times does he cry in 14 days? Now there's 2 ways to solve this. I can first put it in this formula, and I can do a proportionality ratio, which is super useful on the SAT when it comes to these stuff. It's much quicker, but there's an exception in when to use that. So I'm going to solve both ways and explain when we can use each way. So I'm going to start with I'll start with actually the proportional ratio. Why can I use a proportional ratio? So let me set it up first and I'll explain. So they said 3 cries, that even makes sense here, in 1 day. How many times does he cry? So we don't know how many times he cries. So I'm just going to put x, cries, in 14 days. And it's going to be the same ratio. This represents the slope and this represents the slope. So that's why we can set them as equal to each other. And then we're just going to solve for that. So 3 times 14 would be, let me just write that on the side actually, 42. So 42 cries, and 1 times x, so he cries 42 times in 14 days. If we set up like this to solve for x, we found how many times he cried in 14 days, and that's 42 times. And we were able to use the proportionality rule that I explained here when we make the slopes proportional, because the question isn't asking for the formula as it is, they're just asking for the number of times he cries. There isn't a y-intercept that gets in the way that we don't know about. So this is really quick and easy. Now they may ask for it in a formula. So we can write that where y is the amount of time he cries, y. And as we know, it's 3 times every day. So we can put the slope as 3 every day. So x is for each day. And and then they said how many in 2 weeks. As we know, 2 weeks is 14 days. So we just replace 14 in the place of what? And x. So y will be equal to 42. That's the amount of times he cries, like we said before. So those are the 2 ways to solve it. And it depends on the question which way you want to use, but I said I'll explain both. Now, one very important note to have, or a trick to be aware of, is when they give you a slope that gets affected by something. What do I mean by that? Well, let's say there's an increase or decrease, like I said, like a slope. Increase or decrease. Right? So the increase or decrease, they say every, let's say, c seconds. So something increases or decreases every c seconds. So they mention it's not just one increase. They tell you when does it increase? When we have something like this, increase or decrease is the slope, we're just going to take that. This is not the direct slope. This is, let's call it x, right? Increase or decrease every c seconds. To find the slope, which I'm going to represent here by m, we have to take the increase or decrease divided by this rate every c seconds. So x divided by c will give us the slope. You're going to be like, wait, what does this even mean? This is just, let's keep it aside, and solving the example will explain everything. So here they said, Princess Sarah receives 6 gifts every 4 minutes. 6 gifts every 4 minutes. Set that up as an equation. Now some students may say, okay, y equals the increase was 6, that's a slope. 6 gifts every x minutes, and we'll get how many gifts she has. That's incorrect because what happened to the 4 here? There is an increase, there's a rate. It increases by 6 every 4 minutes, meaning 6 divided by 4 is the slope, and then we can have x represent the minutes. How? Let's prove that that made sense. So say we did the first way the student mentioned, y equals 6x, and we said 4 minutes, and we're going to put it here, 6 times 4, 24. Well, that's not true. They said she receives 6 gifts every 4 minutes. Here, when we put 4 in the place of minutes, we got 24 gifts. So that's obviously incorrect. In this method where we divided to get the slope, if we replace 4 here in the place of x, 4 will cancel out with 4, allowing 6 to be the number of gifts. And that's correct. Every 4 minutes, she gets 6 gifts. So this is how we set up an equation by following this rule when it has, a rate. So increase or decrease every how many, whatever, we set it up like that in a division, in a ratio. And the last concept you'll want to understand for these type of questions is the absolute value. And this comes in really handy when there's an increase or decrease, but it doesn't matter whether it's increasing or decreasing. They just want the value of the number as it'll affect the equation. In this case, we're going to use the absolute value. And I'm just going to review that, how in the lines this will represent the absolute value of 5. And the absolute value of 5 is just 5 because we just want the value, not the sign. We just want the positive value, and say the absolute value of -3 is 3 because we just want the positive value. We don't want positive or negative. -3 is 3. So these are the absolute values, and it'll come in handy in questions like this. This will help us really understand what's the point of absolute values in this lesson. So this question says it is 30 degrees Celsius in Dubai today. Every 1 increase or decrease in degrees Celsius results in 4 people entering Dubai Mall. If it is X degrees right now, how many people are in Dubai Mall right now? Now, it doesn't matter whether it's increasing or decreasing. They just want the difference from 30 degrees. So anything above or below will result in 4 people entering. So every 1 increase or decrease in degrees will result into 4 people entering the mall. So if it's X degrees right now, how many people are in Dubai Mall right now? So they said the original was 30 degrees. Anything above or below that will result in 4 people entering. So we could just write that as an absolute value, where the absolute value of X minus 30 will represent the change. How? Let's say X was 31, right? 31 minus 30 would be 1, and that's the change from 30. And if we put 29 in X's place, 29 minus 30, that will result in -1. But the absolute value of -1 is just 1. And that's 1 from 30, 1 below 30. So it doesn't, we won't want the sign, we'll just want it as positive. So this is the perfect way. So having the absolute value is the perfect way to represent the number, where it doesn't matter if it's increasing or decreasing. So this can be set up for the degrees, and then we can multiply this by 4. So if it was 1, it would be 4. If it was, 2, it would be 8. This is the perfect way to represent it. So yeah, we'll keep this as y, the number of people in the mall. This is how we would set up the equation for this question. So that's when absolute values come in handy. It's really helpful to understand this concept. Okay, so on to the first question. All the practice questions that we're going to solve together today are straight from Khan Academy. So if you don't want to know these questions and you want to review from the website, I recommend that you solve them yourself and then come back for this video for explanation. Or sometimes it's best to, just explain the questions really well and then do some practice tests. So whatever method you decide, I just want to make sure you guys know these are from Khan Academy. Now, this first question says, a meteorologist estimates that on a sunny day, the air temperature decreases by about 4 degrees Fahrenheit for every 1,000 feet of elevation gain. On a certain day, the air temperature outside an airplane flying above Seattle is negative 58 degrees Fahrenheit, and the ground level temperature in Seattle is 70 degrees Fahrenheit. If X is the height above Seattle in feet at which the plane is flying, which of the following best models the situation? Now, first thing I recognize is the slope, where they told us it decreases by 4 for every 1,000. And like we mentioned before, when they have a decrease for a number for every another number, we're just going to do that ratio. So decrease in 4 for every 1,000 feet. And it's a decrease, so it's negative. This is the slope right here. And this is for elevation height. So that's the slope right here. So as we see here, we're just trying to find the equation that represents this, and we found the slope. And for this specific, situation that they're trying to represent is when they said that the air temperature outside an airplane above Seattle is negative 58 on the ground level, and the ground level was 70. So originally, in this specific situation, it's negative 58, right? So we want to keep y negative 58 for the air temperature. And originally, or like on the ground, it was 70. And then the slope, negative 4 over 1,000 x. Now, x will represent the height where we got this air temperature. So I would say this is the equation that represents the situation here. So let's see which option matches our answer. Now, I can tell that these two are completely wrong because with negative 58 on the side, these sides don't look like ours. So those two are wrong. A and B. So I can see that they have the slope with 58. So I'm just going to take the slope here. So it's going to be negative 58 plus 4 over 1,000. X is equal to 70. And as you can see, that's the same as B over here. Here it's still negative. When we took it to the other side, this was positive. Negative 58 is equal to 70. Yes, this is B. So B is the correct answer in this question. Now for this question, they said in the year 2006, the average home price per square foot in a certain country was 98. 2006, it was $98. For each year before or after 2006, the average price per square foot increased by approximately $3.5. Which of the following years could be the average home price per square foot? The average home price per square foot would be $119. Now they told us that the year 2006, it's 98. Every year before and after 2006, it increased by 3.5, regardless if that was before 2006 or after, as long as there was an increase. So right off the bat, I can tell this is dealing with absolute values because they don't care if it's negative or positive. And we can just represent the years by saying x minus 2006. That way, if it's more than or less, it will still give us just the number of years after 2006. And they said every year after or before, it increased by 3.5. So we can multiply this by 3.5. Now, this is the increase for every year, but it was originally 98 before any increase. Meaning if we put 0 in the place of x, it will just be 98 for that year, which is 2006. This be 0 years before or after 2006. Now, since we have our equation set up like this, they said they wanted it for when the price was 119. So we're just going to set this to 119 and solve for x to find the year before or after, depending on the two possible dates. Now, first thing I'm going to do is take 98 to the side, leaving, rewrite this, 6, 3.5 equals 119 minus 98, that's 21. And then to get rid of 3.5 here, I'm going to divide by 3.5. This will go with this, leaving us with, actually let me write this up here. Absolute value of negative x minus 2006 equal to 21 divided by 3.5 would be 6. Now, when we have an absolute value equation set up like this, the only way to solve it is, since anything here could be positive or negative, we're just going to make what it's equal to once positive and once negative. That way we can find the two possible values for x. So I'm just going to say x minus 2006 is equal to 6, or the other one, x minus 2006 is equal to negative 6. And take this to the other side, this to the other side. X is going to be equal to 6 plus 2006, which is the same as 2012. And the second one will be x equals to negative 6 plus 2006, leaving us with 2000. So these are the only two possible years where the price could have been $119. So we can tell by the options, C is the correct answer for this question. Now on to the third question. They said a popular candy is manufactured to weigh 0.16 ounces per piece. The pieces are sold in packages of 36. If the allowable amount of variation in weight for one piece of candy is 0.03 ounces, which of the following equations can be used to determine the highest and lowest allowable weight W for a package of 36 pieces? Assume that the weight of the package is negligible, yeah, okay. So right here they told us that there's 36 pieces in a candy box or whatever package, and each piece is supposed to be 0.16 ounces. However, there's an allowed variation of 0.03. They want us to find the absolute highest and lowest possible candies, with the variation being to the maximum, of course, for each one. And we just need to represent this in one of the equations they gave us. Now, first thing I'm going to do is find the weight of a normal package where it's the exact amount of weight they want for each candy. So we're going to say 36 multiplied by 0.16, right? And this is going to equal 5.76. Now, let's say that the actual weight for the highest and lowest, we're going to represent that with W, was minus by the supposed rate, or the weight for the perfect package. If we minus this, we'll get how much extra there was in that package. And I'm going to just take the absolute value just in case it's the highest or lowest. We still want the number. We don't want the, negative sign if it were less. So this will be the weight of the highest or lowest. And we want to make sure that this allows only the variation to be 0.03. So let's say this was equal to the variation 0.03 multiplied by 36, assuming that every single piece had the maximum variation, whether it's more than or less than, because this is negative or positive, it doesn't matter. So we're just going to set it up like this. This will be the equation. And now, since we can't find this in the options directly the way it's written, I can tell that they divided by 36 here. So I'm just going to take 36 to the other side, see if our answer is from the two ones that I saw. That now we'll have W, the absolute value of W minus 5.76 over 36 equal to 0.03. Here it's option B. So I can tell that this is the correct answer for the question. Now for the, I think, fourth question, they said the maximum activity level of a particular enzyme is 60 micromolars per minute and occurs at temperature 20 degrees Celsius for every 2 degrees Celsius above or below 20 degrees Celsius. The enzyme activity decreases by 8. Which of the following equations can be used to find the temperatures T at which the enzyme activity level is 40, I think this is micromolars per minute. Now, first thing I noticed is that there's two concepts from the one we explained. They said straight up above and below, y'all know that's absolute value. And they said for every 2 degrees Celsius, it decreases by 8, meaning there's a ratio in the slope. Now, let's see. Let's first write the slope. No, actually, let's first write the temperature. They said it's originally 60. Wait, hold up. Let's first write 60, right? So originally it's 60 micromolars per minute and occurs at a temperature of 20 degrees Celsius. For every 2 degrees above or below 20, it decreases by 8. So it's originally 60 and it decreases by 8 for every 2 degrees Celsius. And this is above or below 20, meaning if the temperature We want the absolute value of the temperature. So let's say T minus 20. So anything above or below. If we set it up like this will give us the temperature above or below. And for every 2, if it was positive or negative, it doesn't matter because it's an absolute value, it will decrease by -8. So let's just write that here. So why this works, so say T was 22, right? That will leave us with 2. 2 will cancel out with 2 and it will decrease by -8, just like they mentioned here. So they said every 2 degrees decreases by 8, and we know that's written as a ratio when it says it decreases by this for every whatever. And again, they said above or below 20, so we're just going to write T minus 20 to get whether it was negative or positive. We just want the value. And they said, which of the following equations can be used to find the temperature at which the enzyme activity is 40? So originally it was 60, but they want to see when this is equal to 40. Now this is the equation. So based on what I can see, the options don't have a ratio, but we can simplify this here by having -8 divided by 2, -4, multiplied by the absolute value of T minus 20 to be equal to 40, like they want. And that is available in option A. So A is the answer to this question. And now for this question, they said Uchi is a cartographer. He picks a scale to fit a map of India onto a page of an atlas. The page is 12 by 12 inches with 0.75 inch margins on all 4 sides. India measures 3,214 kilometers from north to south and 2,933 kilometers from west to east. Uchi wants the longest dimension. I hope I'm pronouncing his name correctly. Uchi wants the longest dimension of India to fit exactly in between the margins of the page. If K is the number of kilometers per inch in Uchi's scale, which equation best models the situation? Now for wordy, meaty questions like this, I'd like to draw drawings, and since this is basically a paper, perfect, we're just going to draw that. Oh, they said 12 by 12, so it's going to be more, something like that. So 12 on both sides, and they want a margin of 0.75, yeah. Write that better, 75. Say there's a margin here. And they said, and they said that he wants the longest dimension to fit exactly between the margins of the page. The longest dimension is this right here, not this, 3,214. So they want it to be from north to south. Has to fit exactly here, right? And what's the space in between here that it can fit? So we know that this side is 12, but we're going to minus the margins. And since there's two 0.5 margins, we're just going to multiply by 2 to find that this is equal to 1.5. And now we have 12 minus the space taken by margins from both sides. So 12 minus 1.5 equal to 10.5 inches. This is the space we have for this dimension. So they said if K is the number of kilometers per inch in Uchi's scale, which is the following best models the situation. So K is for kilometers, I'm gonna write kilometers per inches, which is the equation that best models the situation. So we have the inches. So if we multiplied K by 10.5, this is by inches, this will cancel out with this, leaving 10.5 times K to be equal to the kilometers, and we said this is the value for kilometers. So let me just actually make space for that. So this is how it's supposed to look. So 10.5 K equals 3214. This is a comma, so I don't know. So is that an option here? Yes, D, right here. So D is the answer for this question. So for this question, they said Elma and Erica work part-time stocking shelves at a grocery store. At 7 a.m. on Saturday, Elma begins unpacking boxes at a rate of 1 box every 6 minutes. So 1 box every 6 minutes, we know it's a ratio, 1/6. That's her rate of unboxing or unpacking. Erica joins her at 7:45 a.m. and unpacks 1 box every 5 minutes. So Erica's rate is 1/5. When finished with this task, a total of 24 boxes have been unpacked since 7 a.m. If X represents the number of minutes for which Alma has been working, which of the following equations best models the situation. Now, X represents the time Alma has been working, not Erica. And we know that Alma worked the whole time from 7 to whenever they finished. So I can represent Alma's time as X. So Alma's time as X. Now, Erica joined her at 7:45. So whatever amount of time Alma was working, she did 45 minutes less than this. Erica joined 45 minutes later. So we can say Erica is X minus 45. So this is the time they both spent, and we know Alma works at this rate and Erica works at this rate. Now, knowing these key information, we can write it as an equation. So let's say Alma works as 0.6 for X minutes, so one box. Let's even write it so it can be clear for you guys. So one box every 6 minutes for X minutes. And this will, of course, cancel out and leave us with the boxes, you know? So since y'all understand that part, now I'm just going to write the equation. So 1 over 6 X for Alma plus the 1 over 5 and Erica's time. So X minus 45 for Erica. And they did a total, barely have space. Now when they finished working, they had a total of 24 boxes complete. So this is their equation. Let me just get rid of this. Now, let's see the options. I think, yeah, A is the correct answer. It's exactly as we mentioned. So A is the correct answer for this question. They wrote, yep, everything's the same. So this is the correct equation to represent the situation above. So on the last question, they said on January 1st, 2014, approximately 450,000 buildings in the United States, had solar panels. This number increased by a total of 180,000 over the next 12 months. Assuming a constant rate of change, approximately how many months after January 1st, 2014 would 900,000 buildings in the US have solar panels? Okay, so let's break this down. This date, they had 450. And their slope increase was by 180,000 over the next 12 months. So 180,000 over 12 months, 180,000 over 12 months is the same as saying 180,000 every 12 months. So right here, we remember this is our ratio situation where this represents the slope and a ratio. 180 over 12 months, that's the slope, and it increased by this much, right? And assuming how many months after January 1st would they have 900? So they already had 450 originally, January 1st, 2014. Plus, of course, their rate for every month afterwards. How many months would it take for them to get 900? So we just set this equal to 900, and to find X, we'll be able to find approximately how many months it took to reach this number. So let's take this to the other side. That'll leave 100. Actually, let's simplify this. 180 divided by 12, I think, would be 15. So 15x equal to 900. We took this to the other side. That's going to be also 450. And then we're going to divide by 15 to get x alone. X is going to equal 450 divided by 15. That's 30. X equals 30. So approximately 30 months after January 1st, 2014, they will have 900,000 buildings in the US. So the answer here is 30.